So hi students. So here we have to find out the transfer function for this block diagram. So here this is the block diagram which is having summing points and takeoff points. So here to reduce this one block diagram, then we can easily find out the transfer function C by R. So here is a takeoff point. So I am moving this takeoff point from this position to this position. So here C. So here is a connection instead of here. So and hence I am connecting one more block here with the gain 1 by G3. So now here I am applying series connection now here G to G3. You can get the G to G3 block. Now here is a 3 input summer. So here to apply the feedback connection here, so we just split this summer into 2 input summer. So here 3 input summer becomes 2 input summer. In this way, split that one to 2 input summers. And now here is a feedback connection. So feedback connection formula means G to G3, here is a plus, that's why 1 minus G to G3 H3. So now it becomes like this. Feedback connection value. Now here if you see, so here again a feedback connection, but here is a one more takeoff point. So here we have to shift this takeoff point to this and then we can easily simplify this block. So here we are using the takeoff point movement from this position to this position. So okay, here if suppose block is there, input is here, takeoff point is here, 2 branches are there, then if you shift this position to here, so that means here is a reverse path. Likewise, block before we are moving the takeoff point. So here is a takeoff point with the gain, this one, same gain. So it looks like a movement of the takeoff point to the before the block. Right. So now here same technique. So here I am moving the takeoff point from this position to this position. So here is a, so already we have here H1 by G3. Since here we are applying series connections, so here is a H1 by G3. So now here H1 by G3, so same gain value, and here I am moving the takeoff point from this position to this position. So now I am using the one more block with the same gain H1 by G3. So now here is a branch. So from this we are having 2 lines. One is to this one is to this one. So this is the individual feedback connection. So then we can easily simplify this one. So now see this. So by applying the here series connection and feedback connection at a time, now you can get like this series connection value and then feedback connection value. Feedback connection, here is a minus, here is a minus. So I am using this one divided by 1 plus this one into this one. These two gains multiplications. Right? Now here after getting the simplification you can get the value. Now here I am substituting that value here. Now the block diagram here simplified as like this. Now apply the series connection and then so feedback connection. So you can easily get the answer. That means simplified single block here. So here series connection means G1 into this one. And then feedback means here is a minus. That's why product of these two after completing series connection. Then this one is divided by 1 plus product of this one and this one. Now here I am simplifying. So the simplified answer is this one. Understand? Now coming to the here signal flow graph. So here this is the given block diagram, same block diagram. So as we seen in the previous. Now here for this we have to establish the first signal flow graph. So in this first let summing points as S1 and S2 and takeoff points as T1, T2, T3. So here if you observe, first put the nodes here S1, S2, T1, T2, T3 and then so here is a node. Now here to this node we have the one incoming and another incoming and also one outgoing. That means two incoming and one outgoing with the gains H1, H2. Here is a 1 gain. That means here is a 1 and then here establish one branch with the gain G1 and here from T1 to S1 here is a minus symbol, minus sign. That means product these two, then you can get the minus H2 gain. So use the direction like this. So in this way, after completion of S1 node, coming to the S2 node. In the S2 node also, we have the 3 incoming and 1 outgoing. So here is a branch from S1 to S2 with the gain G1. And here is a one more branch with the gain. So here is a minus, that's why minus 1 from T1 to S2. And T3 to S2, we have the one more branch, that is H3. Now coming to this one, here is a branch, another one node. What is that? T2. T2 we have one incoming and two outgoings. So here is a G2 and after that H1 to the T1, G3 to the T3. Now at a T3, here is a these two. Now at a T1, so here minus into H2 and then minus 1 then. So here in this way, after placing the nodes here, so you have to draw all the branches like this. Then this is a signal flow graph and then by using Mason's gain formula we are finding transfer function summation del k tk by del. Here k number of forward paths. Here after observation how many forward paths are there? So only one forward path G1, G2, G3. So into 1 means G1, G2, G3. Only T1. There are no other feedback paths here, forward paths here. Now coming to loops. So number of loops here. So here L1 that is G2, G3, H3. G2, G3, H3. So this is the one loop. So gain is G2, G3, H3. So another one is here, this one. So here G2, H1, minus 1. That means minus G2, H1. It is L2. Now L3 is nothing but G1, G2, H1 minus H2. That means minus G1, G2, H1, H2. So L3 is this one. That means here G1, G2, H1 minus H2. So that's why minus G1, G2, H1, H2. So how many loops? 3 loops are there and after observation here there are no non-touching loops. So on 2 non-touching loops, 3 non-touching loops are 0 here. So, okay. So now according to Mason's gain formula, we have here found what is that? K1, number of forward paths 1, that is G1, G2, G3. Number of loops to find the del value. Here is a L1, L2, L3 and there are no non-touching loops. That's why del is equal to here 1 minus summation of all individual loops plus summation of products of two non-touching loops and so on like that. So here is a 0 values. So now here 1 minus summation of all individual loops. So here I am placing the L1, L2, L3 here. Now we have to find out the del k. Del k means here only one T1. That's why we have only del 1. Del 1 due to T1. That means del 1 due to T1 means here is a T1. So we have to observe is there any touching loops here to this forward path. That means in that L1, L2, L3. So is there any loop that is not touching to this forward path? But here there are no loops here. All the loops are touched with this forward path. That's why here. So L1, L2, L3, 0. If you substitute L1, L2, L3, 0 here, del is equal to 1. That is here del 1. So del 1 is equal to 1. So what is the transfer function? Del 1 T1 by del. So here is a del 1, 1 into T1 means G1, G2, G3 divided by del. Del means 1 minus L1 plus L2 plus L3. So here this is the final value. So which is similar to this value. So here in this way we have to find out the transfer function for both the cases. That means from the block diagram and also from the signal flow graph. Thank you.